if you remember in previous class, we have started with fluid and electrolyte balance and acid-base regulation. Yes or no? Yes, definitely. Okay. So, in case of renal system, first we'll be able to understand what do we mean by acidosis, alkalosis, whether it is different for acidemia or alkalemia. Okay. What is the normal pH of ICF? ICF. We are not talking of ECF, we are talking of ICF. So, what is the normal pH of ICF? Anybody from here? What is pH of ICF? No need to discuss. If you know it, please let me know. Correct. It is 7.2. pH of ICF is 7.2. pH of ECF when taken average is 7.4. Clear? Now in biochemistry, you have already done or you might be knowing or doing about the acid-base regulation, in which you will be taught about Henderson equation. Okay, because this hydrogen ion or proton concentration is in nano quantity, so we take a negative logarithm of this concentration and the value which comes out is 7.4. Okay, so simplifying this equation, okay, Henderson equation, it comes that pH is equivalent to bicarbonate upon partial pressure of carbon dioxide. When we are talking of bicarbonate ion, okay, it runs into, what is the quantity of bicarbonate or unit of bicarbonate? It is milli equivalent. When we are talking of partial pressure of carbon dioxide, it is millimeters of mercury, 40 millimeters of mercury. So when we place this simple equation, okay, in biochemistry, the question might come about the Henderson equation or the detailed analysis and interpretation of this equation. But for physiological concepts, you just remember that this equation, okay, is pH is equal to bicarbonate upon carbon dioxide. Okay. Now this unit of bicarbonate and carbon dioxide is different, but the idea which this equation tries to give is pH is directly proportional to the concentration of bicarbonate ions and inversely related to carbon dioxide. When we are talking of physiological systems, okay, there are two terms, acidosis and alkalosis, and these two terms are further divided into it is further divided into respiratory acidosis and metabolic acidosis. हेलो हाँ वो पावरपॉइंट लगवाना था पेन ड्राइव पे एलटी बन So to easy way to evaluate whether the acidosis is occurring due to change in the partial pressure of carbon dioxide or due to change in the bicarbonate ion concentration, okay, that will give us the idea whether this acidosis or alkalosis is metabolic or respiratory. Now, what is the function of buffer? Buffer will try to control or it will resist the change of pH. Okay, it will try to resist the change in pH. So, what are the three main buffers present in the body? the three main mechanism which runs into body, okay? Because the beauty of the body is it is having such a perfect and precise regulation of this pH is the buffers which come into action within seconds. Okay, so they are fast, but they are of short duration. Example of this is bicarbonate ions, protein buffers, hemoglobin, plasma proteins. So they are present. Okay, they are fast and for short duration. If we are talking of buffers which has to come into action for a longer period of time, then we need to study about the renal system. So for handling the change in pH for longer duration, the renal system comes into action, and that is why one of the homeostatic function of the renal system is regulation of pH. Now this regulation is done mainly primarily by bicarbonate ion. But when we know that certain organic acids or fixed acids are getting formed, okay, when some proteins, amino acids which are having sulfur or phosphorus present in them and their metabolism takes place, it results into the formation of sulfuric acid and phosphoric acid, and these acids, they have to be removed by renal system. तो PCT पे कौन सा वर्क करेगा बफर? बाइकार्बोनेट. ठीक है, PCT पे कौन सा बफर वर्क करेगा? बाइकार्बोनेट आयन. और जब हम जाएंगे कलेक्टिंग ट्यूब्यूल्स पे या मेडुलरी कलेक्टिंग डक्ट पे, तो कौन सा बफर एक्ट करेगा? अमोनिया बफर, फॉस्फेट बफर्स. ओके, these are the important buffers which are present, but the renal buffers, they will be acting for longer duration. So, क्या हो? Attention? The major factors involved in the maintenance of acid-base balance and normal pH is this. Okay? दिख रहा है पढ़ाई आ रहा है? Read active tissue. Okay, so this is the most common reaction when it carbon dioxide water, it mixed to form what? Carbonic acid. Is it a weak acid or a strong acid? Weak acid. So it partially dissociates. Okay, in what form? Hydrogen ion and bicarbonate ion. Till now, I hope 10% of the students are clear with the concept of the nephron, that which section of the nephron is involved in exchange of hydrogen ions, okay, or protons, because we are dealing with acid base regulation. तो अभी अपन आज केवल हाइड्रोजन आयन या प्रोटॉन की बात करेंगे कि कौन सा सेगमेंट नेफ्रॉन का है जो कि उसको सिक्रीट कर रहा है और कौन सा है सेक्शन जो उसको रीएब्सॉर्ब कर रहा है. दिस कॉन्सेप्ट यू हैव टू कीप इन योर माइंड. ओके, now buffer systems can temporarily store proton, okay, and thereby provide short term pH stability. It is a short term process. The respiratory system plays a key role by eliminating carbon dioxide, plays a major role by secreting hydrogen ions into the urine and generating buffers that enter the bloodstream. Hydrogen ions comes or get removed through the urinary system or through urine, but the bicarbonate is getting reabsorbed. Okay, pH of urine varies widely, but average is 6, slightly acidic. classes of acid, fixed acid and organic acid. Okay. So if there is change in the concentration of carbon dioxide, okay, the simple equation is pH is bicarbonate by carbon dioxide. Okay. So if we assume that the bicarbonate concentration is constant, that it is not getting changed, okay, and there is only change in the value of carbon dioxide. So if there is decrease in the partial pressure of carbon dioxide, what will happen to the pH? It will increase. So if it is increasing, what it will do? It will result into alkalosis. Just the reverse, when there is decrease in the carbon dioxide concentration, sorry, increase in the carbon dioxide concentration, there will be decrease in the value of pH. Now, what can be the factors which will turn into these scenarios? Okay, what can be the situation or the condition in which there can be decrease or increase in the carbon dioxide partial pressure? कौन से ऐसे कंडीशन हो सकती है जिसमें कि देयर कैन बी एक्सेस ऑफ कार्बन डाइऑक्साइड और देयर कैन बी डिक्रीज इन कार्बन डाइऑक्साइड? खड़े होके बताओ. Rapid and deep breathing. So what will it do? First of all, if there is any problem in the regulating centers of respiration, okay, and where they are situated? So if there is some problem in the regulating centers, that is going to affect the change in the concentration of partial pressure of carbon dioxide. Another is when there is problem in the respiratory muscles. The signals are coming from the respiratory centers, but the muscles are not able to perform their work. That is work of breathing. So that is another condition in which there will be change in the concentration or the partial pressure of carbon dioxide. Okay, there may be hypoxemia. Okay, so these are the few conditions which will change the partial pressure of carbon dioxide. And whenever there is change in the partial pressure of carbon dioxide, there will be respiratory acidosis or respiratory alkalosis. When these kind of situations occur, the first line of defense for the buffer system is either hyperventilation or hypoventilation. So this is the result of a volatile acid that can be removed through lungs or respiratory system. Just the reverse, whenever there is change in the concentration of bicarbonate ion. So bicarbonate is directly proportional to pH. Okay, so whenever there will be decrease in the bicarbonate ion, there will be decrease in the pH value. That means the condition becomes acidic. Clear? So that is metabolic acidosis. Whenever there will be increase in the bicarbonate ion, there will be increase in the value of pH. Increase in the pH means alkalosis. So in problem solving questions, you get the values of. So suppose the partial pressure of carbon dioxide remains 40 in your question, but there is change in the serum bicarbonate ion concentration. Okay, so you have to apply your brain that which type of acidosis or alkalosis is taking place. Okay, just for understanding point of view, we are assuming that the one numerator or the denominator, if it remains constant, and if there is change in either of the numerator or the denominator, what will happen to pH? Clear? Third row. What can be the condition in which metabolic acidosis takes place? इतने सीरियस क्यों हो गए? बहुत कॉमन चीज है जो कि आप लोग सुनते भी हो। डायबिटिक कीटोएसिडोसिस क्या होता है? अभी तीनों आप डिस्कस कर रहे थे कुछ बहुत इंपॉर्टेंट, इसलिए मैंने कहा पता नहीं कुछ ज्यादा एक्स्ट्रा पता चल गया हो तो। मैंने क्लास की स्टार्टिंग में भी कहा था कि आई डोंट वांट टू स्पीक एनी बैड थिंग्स अबाउट यू, बट इफ यू वांट let me also continue. So acidemia is more common due to acid producing metabolic activities. Okay, effect is CNS functions deteriorate, most important. If there is sit down, if there is deterioration of CNS function, it may result into coma. Okay, ketoacidosis is the example. Cardiac contractions grow weak and irregular. Okay, peripheral vasodilation causes blood pressure to drop. Okay, increase in this that is acidemia is increase in the hydrogen ion. So what it will do? It will do the vasodilation. So this is only the role of hydrogen ion or decreased bicarbonate ion concentration, but what effect they are taking place. Okay, alkalemia more than 7.45. Physiological state can be dangerous, but relatively it is rare. Important terms relating to this acid-base regulation. Okay, I think this is the narrow range of normal pH of ECF and the conditions that result from pH shift outside the normal range. Okay, so why it is important? If it is below 7, can be deadly. As we know, it is affecting the central nervous system. Okay, cardiac contractions grow weak, peripheral vasodilation. Okay, severe alkalosis is also dangerous, but serious cases are relatively rare. It is more of the acidemia or acidosis that takes place. Okay, CO2 partial pressure effects on pH. So that is reversible reaction that can buffer. This is the balance. Okay, 40 to 45 millimeters mercury of carbon dioxide partial pressure. Okay, this is homeostasis. The range is 7.35 to 7.45. If CO2 rises, that is the condition. Okay, if CO2 falls, increase in pH. Okay, substances, what are buffers? The three major buffer system, it can temporarily affect pH. That is, hydrogen ion is not eliminated or removed. Phosphate buffer systems buffers pH of ICF and urine. Carbonic acid bicarbonate buffer system, most important is ECF. Okay, fully reversible and it can reserve itself. The three major buffer systems continued is protein buffer. Plasma proteins are better buffer or hemoglobin is a better buffer? Last row, plasma proteins are better buffer or hemoglobin is better buffer? Last row, huh? Plasma proteins. Can you explain? और किसी के पास है इसका explanation? Sit down. Plasma protein is extracellular fluid compartment, okay. But what is the concentration of plasma protein and what is the concentration of hemoglobin? First important question of blood is functions of plasma protein, in which you have to give the concentration of plasma protein. What is their concentration? Within a month we are having another exam. Okay, sit down. Okay, protein buffer systems usually operate under acidic conditions, binding to carboxyl group and ammonic group. Okay, only intracellular system with immediate effect. It is present only intracellular, so it is intracellular. and with immediate effect. Amino acid buffers all proteins and plasma proteins. Intracellular में phosphate buffer, protein buffer system, ECS में protein and carbonic acid bicarbonate buffer. Okay, the events involved in functioning of hemoglobin buffer system. Okay, what happens if a person has is having vomiting? So what will be the condition? Phosphate buffers और buffers और pH regulation के साथ में एक important term होता है, that is anionic gap. Okay, you get a short note on what is anionic gap. So anionic gap is sodium ion minus, that is bicarbonate ion. Okay, so the difference of these two, okay, plus chloride ion, bicarbonate and chloride, they are added and subtracted from sodium ion. So the difference between the sodium and the combination of bicarbonate and chloride ion, that gives you anionic gap. If that gap is of 12 units, okay, then that is normal anionic gap. But if it is more than that, then it becomes hyperanionic gap. Okay, so this anionic gap is responsible for classification of metabolic acidosis or respiratory acidosis, or metabolic alkalosis or respiratory alkalosis. You get a definitely you get a short note on anionic gap. So in your tutorial register, please, today's task is add a short note on anionic gap. Anionic gap. What is the normal value of anionic gap? Okay. And what happens if this anionic gap value varies? And get your register today, whichever batch is coming, and from today the PSM or the community batch is going to come in hematology lab. We have already placed the timetable. If you have seen, yesterday we have done a revision, timetable आपका बनाया नया, उसके अंदर community वाला batch जो है वो hematology lab में आएगा. कल वाले batch के absent लग गई है, आज जो batch आना है वो देख ले अपना timetable. Okay? क्या? क्यों? क्योंकि we have to complete 320 practical hours of physiology. It is not we कि क्यों, it is NM. Okay, so we are trying to complete it. So the third batch has to come for hematology revision practical. Okay, just go through the timetable and whichever batch has to come. And get your manuals along with the all the manuals. What I say is, clinical, hematology, your logbook, okay, your competency manual, that has to be corrected, plus your tutorial register. है ना? Okay, steps in carbon dioxide removal through the renal system. Just the flow chart of respiratory and metabolic acidosis, very subjective topic, okay. Just try to focus on these 3 or 4 slides. If you will, you want to copy it, just copy it, write it down, because this is going to give marks or adding marks to your paper. Clear? अगर आप इतनी कहानियाँ लिखेंगे and all rubbish. Yesterday I had gone for copy correction and it was all, जो कॉपी किताब कहीं पे भी नहीं है ना, वो सारी नई डिस्कवरीज मिली है कॉपीज में, यूनिवर्सिटी कॉपीज में. सो दैट वाज हॉरिबल पार्ट. आई कैन नॉट एक्सप्लेन यू कि कितना गंदा था वो कॉपीज का. दैट इज वाई मैं बता रही हूँ कि आप इन पर्टिकुलर स्लाइड्स को या फ्लो चार्ट को प्लीज फोकस करके लिखिए, बिकॉज वॉट एवर द स्टूडेंट नोज ही और शी राइट वेदर द क्वेश्चन इज देयर और नॉट. क्वेश्चन कुछ और मांगा गया है, आंसर टोटली डिफरेंट. Okay, so homeostasis, normal acid-base balance. Disturbed hypoventilation causes increased partial pressure of carbon dioxide. Elevated results in falls of plasma pH, respiratory compensation taking place by these buffers, combined effect is decreased and decreased hydrogen ion, increased bicarbonate concentration. Again, this homeostasis is maintained. Now, another topic which we'll start is the micturition reflex. Okay, and the last topic will be renal function test and its applied aspects. Clear? So next class will be micturition reflex and another class will be of its applied aspect, and we'll finish it off with the renal system. But along with the renal system, skin and body temperature regulation also comes into consideration, so that will be taken separately.